Hello and welcome to my presentation, tweaking UD annotation to investigate the placement of determiners, quantifiers, and numerals in the noun phrase. We start from the assumption that most of the work using universal dependencies to study variation across world languages uses curated collection of annotated text, the so-called UD Treebanks. When we turn to automatically parsed text, as Lievshina did using Leipzig Corpora in 2019, or as we did in 2022 using Keep Plus, some problems, mostly wrong annotations, arise. The question is, can we achieve a decent quality of analysis by using automatically parsed text? With some tweaks, we can. These are the data sources for 5 quite recent papers on word order variation. Let's be honest here, it's fine to use Treebanks for quantitative research as they are manually annotated or at least checked. They represent training data for quite robust natural language processing parser, so they have to be perfect. However, even if we take 2 widely spoken and national languages such as Hungarian and French, the difference between their Treebanks is striking. An alternative to Treebanks is represented by parallel corpora. Since 2019, Annotated and I've been building Keep Plus, a parallel corpus of Indo-European prose and more. To this date, the corpus has been currently parsed using Stanford Stanza plus Universal Dependency models version 2.8. The short paper is based on a sample of 10 languages belonging to the Western branches of the Indo-European family. All languages except one, Irish, features 120,000 parallel sentences for 1 million of tokens for a total of 8 different texts. The global formula represented here is Shannon entropy, which for 2 possible order of variation, which are the variation of 3 minor word categories in the noun phrase, range from 0, no variation at all, to 1, both word operators are attested with the same probability. We exemplify our methodology on 3 categories that are often confused in the traditional grammatical analysis and challenging from a cross-linguistic perspective. This fact is somewhat reflected in the UD annotation. At the syntactic level, UD relation, determiners and quantifiers are lumped into the determiner relation, while at the word category level, the universal part of speech level, determiners are tagged as that, det, and quantifiers as either det or pron. The simple solution already adopted in early works by Natalia Lievshina is to combine the UPOS and the UD relation, maybe also including subtypes of UD relation and UPOS that are not explicitly designed for that category, such as pron for demonstrative. We add here a third manually carved layer of annotation. Like old-fashioned typologists, we collect data from grammars and we compile a language-specific list of closed class items. We do not throw anything away. The combination of annotation are applied in further steps. The left plot shows the entropy of the different categories as captured by the UD relation only, which is in pink, and by the UD relation plus the UPOS, which is in yellow. When introducing the UPOS layer, we already observe a significant drop in the entropy, especially for the category of numerals, which in 4 languages is reduced to quasi-zero values. This yellow combination of data is however less significant for the other macro category of determiners and quantifiers. This is partly due to the low values of entropy already captured by the rel combination, the pin combination, but it also reflects the biunivocal relation between the det UPOS tag det and the UD relation. By contrast, the num-mod UD relation are not in biunivocal relation with the num UPOS tag, as this UD relation is often used with quantifiers as well. In the right plot, we observe the introduction of the list of lemmata layer, which is depicted this time in black. This introduction is crucial to disentangle the metro category into articles that are demonstrative and quantifiers. Although the entropy of these categories is extremely low, two languages present an intrinsic pattern of variation. Irish has a quite high rate of entropy with respect to quantifiers, and Greek with respect to demonstrative. Also, two other Romance languages, Spanish and Portuguese, have a low to moderate rate of variation with respect to these minor categories. Finally, I also tested this list of lemmata layer approach against the category of numerals, using the list of lemmata layer as a negative match against the lemma field. This was, however, of little use, as entropy values captured by this approach are quite similar to the ones captured by the rel plus UD-parsed approach. So, summing up in a nutshell, we have described a symbol combination of two layers of UD annotation plus language-specific list of lemmata to estimate the entropy of the terminals, quantifier, and numerals in the noun phrase in a parallel corpus of 10 Indo-European languages. We have observed that the quality of the analysis has been improved and that this methodology sheds light on previously hidden categories such as article, demonstrative, and quantifiers. We have also highlighted two patterns, an high to moderate values of entropy for Greek demonstrative and high values of entropy for Irish quantifier. Thank you for your attention.